So last time we worked a little bit on the word problem setting, and the key idea was to read the problem and, of course, to read the question before answering it. It's pretty obvious, but the practice shows that sometimes people take it too easy and don't really pay much attention to the process, and that's the point. And it's true for not just word problems, for just about any exercise that you are going to solve, just to see what they want you to do, right? If you do something else, of course, if you're enjoying it, you can definitely enjoy, but you should not forget to answer the question. So I guess I'll do one exercise because the exercises, the word problems are all going under the same pattern. And let me do, I select, let's say 22. And of course, if you have a preference for some other exercise, just look, I have this textbook with problems opened in front of you, so you can select whichever one you like. We can tackle it together. Why not? But anyways, let me start out with exercise 22. I think it's a pretty standard kind of problems that you encounter in math classes. So you see that 850 per hour is a P. So we already know numbers they give us, we should put down. So I write $8.15 here. Now, tutors will earn additional 220 for each hour of overtime. So overtime, which means that we need to somehow call it as probably letter X. How many hours of overtime we work with, we don't know, and that will be additional. So we'll have to add, right, since it's additional for 220 for each hour, since we don't know what number of hours they're discussing, and probably that's what we're going to need to find out. So I just call it as X. Call it as X hours. I'm going to say, Alex, what if I put 220 times X, not X times 220? Well, it doesn't matter because you multiply so you can commute numbers around the multiplication, right? So looks like we have for first 40 hours. So looks like 40 hours go with 8.15 per hour. First 40 plus extra for the overtime, and that's what they talk about. So here comes the story about the math tutor that worked 42 hours one week and 45 hours the other week. So we can see how much the tutor earned over 2 week period. So it looks like that's what the student works per week, right? 40 hours per week. And looks like this is going to be utilized twice, this expression. So there'll be first week, and then there'll be the second week. And of course, the pay will pile up, so we're going to have to add this all together. So looks like 40 hours at the pay 8.15. We'll have some overtime. And what is the overtime? Well, looks like if it's 42 hours, then the overtime will be 2 hours of overtime. So adding 2 hours multiplied by 220. I say, Alex, is that X or that's times? What does that little cross means? Well, I mean, it's multiplication. I can actually write it as times, but just to make it more visible, I put little cross, a little bit less than the digit. So that's what I'm trying to do. So that's first week. And then the second week looks like we start out exact same way. For first 40 hours, it is still 8:15, but then more overtime happens. It's like those students, tutors get in demand because looks like here we have 5 overtime hours for the second week. So I'll take not 2, but 5. See, now I replaced the 2 hours with 5 hours, and that's what I guess they want me to do. And then it's again times 220, and it looks like that's all we need to do. We need to add those numbers together, and that will be, I guess, the way to go, right? So why don't I try to use my favorite calculator in order not to make a mistake? So let me find if it's open here. Not really. So how do I find the calculator? Remember, scientific. I need to put scientific calculator. I start typing it, it appears already. And I utilize the choice number 1 in Google search, scientific calculator Desmos. Again, you can use any calculator you like, but I prefer to use the Desmos. It's, I think, pretty good, especially for the future when we're gonna do some statistics and other stuff. So it'd be, I believe, very convenient. So you have to add 2 times 220, and that'd be my first piece. I can put it in the parentheses if you want to enter the second week separately. I know there are various ways to do this in terms of enter into calculator. Maybe you can calculate pieces separately if you want to, but I just want to have this all put in the calculator at once. So I forgot it's times 2, right? 2 hours of overtime. Is that the one? 220? Alex, it's kind of 2 times 2.20. Okay, $2.20. I think I then dot. Okay. All right. So similarly, now I change 2 is 5 and go again times 2.20. See, the good thing about this calculator is it allows you to see everything that you enter in, and of course to also fix it. If you think it needs to be fixed, then it allows you to go and fix it, and that's a nice part of this calculator, and the answer is produced $667.04. What is it? That 4 is at 40 cents? I guess it's 40 cents, right? It is 40 cents. So after the decimal, you can put as many zeros as you like, but there is no point. So you just keep it as point like that. So we have here the result, and I guess that's a great start, right? So we can, if you don't have any questions on this,
I
begin.
do. I
Yes.
do, Professor. What if we add first the 8.15 plus the additional 2.20 and then multiply it by 40?
Well, this is price per hour. Oh, I think I didn't do it correctly. That's what you were saying. Yes, yes, I was not very careful because the pay is not 220, right? See, I need to wake up, even though it's already daytime, but I need to wake up. It's additional. So how much does tutor make per week, per hour? 220? No, it's additional, so it's 815 plus 220. I'm not going
Yes,
to tell you that I did
yes.
it on purpose, but
We add them and then we multiply by
yes,
40.
exactly. And then this is what I'm missing. So it's not hard to fix though. You could just put plus 815 because what I did, I calculated that you work more, you get paid less, and this is really disappointing, right? Yes, it's absolutely correct. So I need to probably add this in the parentheses, and that will fix it. So why don't I go ahead and do it? In fact, I think it's good that I didn't do it correctly from first time because now I can again show you my favorite calculator, how I can fix things up. So I can just put 220 plus 815, right? So why do we have to do that? Alex, what are you doing here? Well, I'm solving the exercise, and what I'm doing is calculating the overtime. So it's not 220, but it's also 815 and 220 on the top of it. So actual tutor makes over than $10. And the same thing is here. So thank you for being careful and noticing it. And this is great. So I want to also add 815. One may say it should be 815 in the first place, and then we need to add, not times, but add these numbers. Well, it doesn't really matter what happened here. Well, looks like it doesn't fit, but if you continue, you will be able to see it, right? So it's all there. So it's longer, a little bit longer expression, but now the tutor will be happy because otherwise it'd be unhappy tutor and say, it's all Alex's fault. Alex stole my $20 or actually way more than that, 60 or something. So that's no good. Thank you for correcting it. So I hope now it's a little bit better. So what happens again is, yes, first 40 hours is at 815 rate, but next 2 hours is at the rate of like 1035, right? And this 1035 has to be taken twice for 2 hours or 5 times for 5 hours. So now we're good. Ooh, and that's great, and that feels real good. And you're better than I at this, so I definitely can move on because now we can see what else is going on with this whole story of this nice textbook. So thank you for fixing it. So I go back to the contents and chapter 1, I hope we're done with. So next chapter will be chapter 2 after chapter 1, right? So let's see what's going on here with chapter 2. So I'm going to stop sharing it and then share this again and see how this works when you deal with so-called set theory of sets. And this is something that is very different with what we have seen so far, because now it's going to be dealing with absolutely different area of mathematics. It's completely different area. So let me move to the first story here. So just go to the next page. The introduction is dealing with set theory. In fact, this class is produced from a bunch of totally different topics in mathematics that may seem not to really be related with each other. So set theory is the one that will be quite different with what one used to work with here. And first of all, it deals with so-called sets. So set, which is called a collection of objects that we put together and we need to call this collection somehow. In mathematics, we use word set. And for convenience, for us not to use word set, they coming up with a symbol, which is big braces. Like here, for example, the set they now like to name as W, designed from, looks like days of the week. There are 7 elements, 7 names for days of the week that we use. They placed in those braces and those grouping symbols. So that way you don't have to write word set of days of the week. You just do it mathematically. You put in the braces those elements of the set and have it equal to the name of the set, which is, in this case, they decided to call it as W. Well, probably because it's weekdays, so W for identifying them. So, example of the set. So there are various examples, and they make you get used to them. Those examples, they say the set of various names of presidents, 5 presidents of United States. So here they are. So you can put just any objects together in the braces and that will be set. Of course, it is nice to be able to list all elements of the set together, but sometimes there are so many of those elements that people don't want to list, they want to describe it somehow differently. So instead of just using the listing of all of these elements separately, what they can do is to describe the same set using so-called set builder notation. So what they do is they say all elements of the set called X. Let's say you have to use letter S. You can use any letter. So for convenience, we usually use letter X. And then after this little bar, they say what X represents. And they say it's a day of the week. And that way, we described exactly the same set we just encountered. Monday, Tuesday, Wednesday, etc. through Sunday, 7 elements, but we don't list all those words. We just say it's a day of the week and that's it. So that's an abstract way to describe those sets instead of listing them exactly so everybody can see them. Well, people need to think of what this description actually means. And again, for small sets, probably it's better to just list elements, but this is usually is being used for big sets. So if sets you have lots of elements, then this is a standard set builder process that people are always using. So that's what people are doing. And sometimes, so various exercises that sometimes are better to use just listing of the set elements, like here, looks like they have a set A that has 2 months that start with letter M, March and May, or otherwise they could also use that set builder notation, say all elements called X, so that's kind of standard, and then out of the bar they say X is a month that begins with letter M. So you describe it with words. And say, so Alice, what do you want us to do? How do we describe it? It is up to you. It doesn't really matter to me because I realize that these are the same. So I know that. So that's why I don't want to pick on my students and say, oh, you have to describe it. No, that's fine. You can use either elements or set builder notation as long as everyone understands what those elements are. It is fine. So there are various examples. So I'd like to try to do some particular exercises a little later. So let us move on to the next section of this textbook. So just first encounter sets. So we put them in the braces. And there are various examples of the set, and there are some sets that have nothing in them, empty. So is that possible? Well, for example, you can check, say, left pocket, and if you don't have anything in the left pocket, you say it's empty set. So there is nothing in there. So we put a braces to describe that this is a set. And inside the braces, we put nothing. We don't put zero. I say, Alice, that's zero elements. Or we don't put anything else, but here's a special notation. Word notation means you need to remember it and realize what it presents. So it's like a circle with the empty circle crossed out like that. So please notice it's not the same as a circle and has that dots, a happy face or sad face. So it's not the same. So empty set is a special notation. It means the set that has nothing in it. So no zeros, no faces, nothing, empty, totally no elements. Sometimes it is useful in the set theory, and that's why we have to talk about it. Of course, this is something a little different, but, well, I guess it's good to be familiar. Now, I'm not planning to give you quizzes or any other things related to identifying or remembering these definitions. You can just have them on a piece of paper next to you, and that'd be good enough. So you can always refer to those if you forget, so I don't make you to train your memories. But it is a good idea to have it as a summary, maybe on the page, so to come to realize that this symbol of so-called empty set is present when you do the exercises. So they have example here, so-called A, that has a set that has one element, and the element is zero in it. Just like we could have had a set that has one element, and whatever the element is, like triangle, for example, it's going to be kind of similar set with only one element. Here's triangle and here's a zero. What the element is, we don't care. We can put New York. So the set was one element, which is called New York. So also one element set. But if you had empty set, it'd be the set with no elements at all. So it's not the same to have zero as element and no elements whatsoever. So it's probably worth to think. In fact, I think that it'd be a good idea for me to start giving you a little quizzes as we go along, but not today. Today is a busy day, so I'll just give you a little story and let you go without a quiz. But maybe next time we'll try. In fact, my students always liked quizzes, so I will give you one next time, which is going to be on Wednesday at the end of class. So you will see how you feel about it.
Can I
So-
ask something, Professor?
Yes, please.
Don't we have to buy the book so we can do like the quizzes and assignments?
No, you don't have to.
Okay.
For the homework, I asked you to do the same problems, a few of the same problems that I do in class. So you can select, you don't have to do everything, but just select 2, 3 little exercises, whichever ones you like. So for that matter, all you need is a recording of lectures. So I'm recording the lecture right now. So when you receive after the class ends my email with a recording, then you will be able to click on it and watch what I did, even if you missed the class. or beginning of class or end of class, whatever part of class you miss, you have it all in the report. And I think it's very convenient. In fact, I wish I could get it when I was a student. So usually the professors would just expect me to copy everything they write on the board to my piece of paper. So that was kind of annoying. But in your case, I think it's a great idea to take the online class because you just don't need to copy anything. It will all be emailed to you. So I think it's great savings of time. So you just see what I do and then copy a few problems. Exactly the same solution. So that's why you don't need to buy any books at all. Unless you want to, if you want to start your own math library, you can definitely buy the book. You can buy more books than that. It could be a good start. But I don't make you do this. So it is up to you. If you want, you can definitely buy it. But I don't think I recommend you because you will get the email with lecture recordings. And I guess that's great that you're planning to do something. That makes me happy. That's good. Good. So, anyways, various sets are being discussed here, and empty set is something that we see pretty often here. So, what else? Well, looks like I have to browse through this textbook because that's the only way I could get from topic to topic. So it's a little bit annoying, but I don't have a choice if I want to have a free textbook that I can share with you on the screen of my computer. I guess that's best I can do. So anyways, there are few sets in example 5 here provided, and one of them looks like a set of letters of alphabet, right? So 26 or something letters here, lowercase, and they say is letter R supposed to be among those letters? We say yes, somewhere along the road you will encounter letter R, right? And here it says element of the set. So this symbol means R is an element of that particular set. So what we're doing is we're learning vocabulary for this particular notation. So we're using the new symbol set element. So R is an element of that particular set because it may be element or it may not be an element. Like in example B, you see this element of the set is crossed out. So 7 is not in the set, and they listed the set of digits 1, 2, 3, 4, 5, and looks like there is indeed no 7 in here. So it may be element or may not be an element. I say, oh, that's no good. It is not an element. It doesn't matter. It may be yes or true. People say true statement, or it may not be true. So 7 is not an element. So it is also correct. It is also true. I say, wait a second, it's false. It's 7 is not an element. Yes, 7 is not there, but what are we saying? 7 is not there, so we're saying correct thing. What if I said 7 is an element? See, that's where this true false. I think they throw a little bit more information on us that they did not discuss yet. So here they say, here is a set, for example, 1, 2, 3, 5, and say 4. Well, let's say 1, 2, 3, 5. I just made my own example. Is that going to be correct? Do you see 7 as an element among these 4? I say, no, Alex, I don't see it. So if you're saying no in mathematics, we say it's false. So it's either true or false. say true, false. Can I just say yes or no? Yes, of course, it's fine with me. But you should be able to also understand what they say here in the textbook. So true for yes, false for no. Not just mathematical language that we encounter as well. Interesting, right? So true, false story about our set. And let me try another little exercise. I say, so how many exercises are you doing a day? Well, I'll do probably 20, and you can select any three of them, any ones you like. For example, you can select C and copy it, and what can I do for this exercise? Well, they ask, is this true or it is false? So you need to put the answer, either T or F. Monday is an element of this set. Is it correct or not? Well, let's see what set we have. Day of the week. So is Monday belong to the set of days of the week? Is that true? Well, it looks like, yes, Monday is the first or second day of the week, right? The week starts with Sunday, so Monday is among the days of the week. So it is true. It is correct statement. So it is true. I hope it's not very hard. I knew it's different. I knew it's a little bit new. And again, don't need to panic. You don't have to memorize all that because we'll see more and more of it. And then when the time comes to the test, which is going to be in the middle of semester, the midterm is not soon, but I might give you a quiz next time after I do this exercise. Monday, is it true? It's a day of the week. You say yes, true. I'll ask you, okay, so what about for quiz? What about if I say Sundays? Sunday, an element of the set that this is day of the week. You say, yes, Sunday is also among those days of the week. So it is also true. Okay, that will be your quiz. It's not too hard. So I usually give very similar questions on my quizzes to what we just done in class. So usually if people paying attention, they're fine with it. Or if you were not paying attention, if you were driving and at the moment there was some kind of situation you could not pay attention, no worries. Please don't worry. You can get back to your place or wherever you're driving, and maybe over weekend, check out the lecture recording to see what the quiz was. Do it and email me the answer. The quizzes are usually given such a format that you can just send me the answer, either T or F, so very simple. So you just email me the answer, and that way you will be done with the quiz. I think it's pretty fair, so I don't want to intimidate you with any of those pushing, so you get mass anxieties or stuff. No, we don't need that, right? So why don't I move on to the next page? Just want to clear what I did and see what else is here. So it looks like elements of the set, and I guess they just start to do a little bit more things and get involved more into this. And I don't want to have you involved more because at some stage you ask yourself, why do we need it? Because we need it just for vocabulary. So we know element of the set or not the element of the set, so we can move on and see what else is here, because sometimes you get in too deeply into stuff that we don't really need to worry about. So very popular set of so-called natural numbers. I'm sure you're already familiar with it, and they like to call it with capital letter N. So 1, 2, 3, 4, 5, and so forth. It's a set of natural numbers. Please notice there are infinitely many of them, because no matter how far you go, you can always add 1 or 2 or something else and get another natural number. So people like to put dot, 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 or instead of listing some of them, they write capital N. So this capital N actually represents set of all the natural numbers. Just like that. So set of natural numbers, we use not just N, there's a special kind of N. So it's like that. But people have tendency to remember, or again, if you don't rely on the memories, you can just put the listing of these numbers and have it called with capital letter N, natural numbers. So sometimes you use capital N, sometimes you just use word natural numbers, and that's what they're doing here. Natural numbers. Well, you can work with this set as well. Please notice it's an infinite set. So if I try part C of this exercise, it says element of this natural number set when x is even. Even. Even number you can divide by 2. So number 4 you can divide by 2, right? Number 6 you can divide by 2. Even numbers. 8, 10, 12. I don't want to continue because it's going to take forever. 100, a million, a billion, quadrillion. I say, what about zillion, Alex? Not sure that's what that actually means, but any number that ends with 2, 4, 6, 8, or 0 is called even number. Please notice that set of natural numbers start with 1, so 0 is not present. So in the set E, listing of those even numbers with dot, dot, dot. So that's what it is. So I did my best to list those and put dot, dot, dot. So just listing of numbers with those 3 digits, and that's all it is. Well, please notice they did it here as well. Looks like the same thing. So name of the set, capital N, is very popular, and sometimes they start to do various examples that may not look very attractive when you look at them first. But if you don't hurry and start to think clearly, you will be able to definitely figure out what they're talking about. Say 4, and then 5, and then 6, 7, and 8 is a bunch of numbers that I just circled here, right? But please notice that we don't really have a 4 because x is strictly greater than 4, right? And here's the answer then. 5, 6, 7, 8. So set of 4 natural numbers is here. So they just cut out from this infinite set 4 elements. And that's it. See, we start to talk with mathematical terminology. Infinite set, 4 elements. So 4 elements, but infinite set is here, set of natural numbers. So I'm using the knowledge that we know that n is 1, 2, 3, 4, 5, 6, 7, 8, 9, dot, dot, dot. So it's great to know. I know it's getting a little bit overwhelming, and I know that I promised to let you go earlier today because of weather conditions. In fact, the college is closed, all classes are canceled, all in-person classes, but they said that face-to-face you can do whatever way you like. So I decided to give you a little bit, but we'll stop after this. So I'll do example 7 part A and let you go. I think that'd be fair. And next time we'll start from this part. So how about part A that says express using roster method? So what does that mean? Well, looks like I need to list those set elements differently. Well, that's not what I'm gonna ask you to do for the exercises, but looks like they want you to list elements, so 3, 4, and so forth, all the way to 100. So I can put dot, 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 and then up to 100, right? So it looks like there are 100 elements in this set. So you just, 1, 2, that was 3. So you can even count how many of them there are all here. 100 elements are in this set, just like that. So I use dot, dot, dot in order not to write 100 elements. Well, over the nice snowy weekend, if you have nothing else to do, well, you could write it down. I say, do I have to? You don't have to do anything. In fact, you don't like the exercise. Remember, I told you you can skip it and copy the other one. Because I don't want you to practice copying. I just want you to start to be on the same page with us. And that's the point. So anyways, I guess as I promised, I'm gonna end it for today. So we'll continue on Wednesday. I hope everything will be back to normal on Wednesday. Something happened with a pipe in the college, so there's various issues, but I'm sure they're gonna fix it by that time and everything will be back to normal. So I'm going to stop this for today and thank you for being patient. And in spite of everything, you made it. That's very, very impressive. So next time I will give you a little quiz at the end. We'll see how it works for you because I think we're in a very good shape in terms of running this class. So I hope you're gonna enjoy it. So I'm gonna stop recording this moment and see if you have any questions, please